benvenuti alla quinta conversazione del ciclo La Scienza a regola d'arte. La ormai consolidata collaborazione tra il Museo d'Arte della Svizzera Italiana e la Fondazione IPSA per la ricerca scientifica ci propone oggi una nuova occasione di dialogo tra la creatività e la scienza. E oggi parleremo di invisibile e lo faremo con due ospiti di eccezione. Prima però di entrare nel vivo della conversazione, invito con piacere a raggiungermi Silvia Misiti, direttrice della Fondazione IPSA per la ricerca scientifica, e il dottor Tobia Bezzola, direttore del MASI.
Grazie Elisa. Ecco, direttore al gradino. Buonasera a tutti, grazie di essere qui da parte mia e del direttore del MASI, solo un saluto di benvenuto. Fondazione IPSA nasce dall'azienda farmaceutica IPSA con diversi scopi che sono quelli di sostenere la ricerca scientifica e promuovere la cultura scientifica, quindi siamo sempre molto felici di parlare di cultura scientifica in templi come questi appunto della cultura in senso C maiuscola. Come ha detto Elisa, stasera è il quinto appuntamento di questo progetto molto interessante nato ormai 2 anni fa con il MASI, che ci permette di mettere a confronto due mondi così sembrano lontani, ma stiamo scoprendo evento dopo evento che poi alla fine non sono così lontani, e il nostro scopo è proprio quello di mantenere un filo, un tema che continua, che passa da un evento all'altro, e ogni volta abbiamo dei personaggi sempre più straordinari, devo dire, che vengono a raccontarci attraverso il loro lavoro quello che è la loro opinione su questo confronto tra queste due discipline. Quindi il quinto appuntamento, speriamo, quinto di una lunga serie. Mi fa piacere ringraziare come sempre tutte le persone che lavorano con me, che sono sparse qui intorno, che permettono questi eventi uno dopo l'altro. È un periodo intenso e quindi vi consiglio, vi chiedo di seguire tutte le attività della Fondazione IPSA. A questo punto vi auguro una buona serata, passo la parola al direttore dottor Bezzola per un saluto da parte del MASI.
Grazie, buonasera, benvenuti. Siamo molto felici che siete venuti in tanti. È la quinta volta, come ha detto Silvia, e speriamo di andare avanti perché sta diventando sempre più interessante. E siamo molto felici di avere qui con noi James Beacham, welcome back James, e anche l'artista Andrea Galvani, che voi conoscete, e se no penso che questo anche sia una occasione ottima per conoscerle, perché gli artisti spesso non si conoscono unicamente tramite le mostre, le loro opere, evidentemente per quello che siamo qui è essenziale di anche poter comunicare, di sentirli parlare, di fare delle domande, di conoscere una persona. In questo modo possiamo solamente capire poi il lavoro. Vorrei ringraziare anch'io a tutti quelli, non so, Silvia Misiti e tutto lo staff della IPSA Foundation. È una bellissima cosa per il MASI questa collaborazione, e continueremo anche l'anno prossimo. Vorrei anche ringraziare il nostro staff, tutte le persone che erano coinvolte, Chiara Cubotti, c'è Valentina Bernasconi, come sempre, che ha co-organizzato questa sera. Devo scusare il nostro collega Gregory Beard, che è proprio lui, che era l'uomo dietro questa serata, che purtroppo si è ammalato e non può essere con noi. Allora passo la parola e andiamo direttamente.
Andiamo avanti.
Sì, andiamo avanti. Grazie.
Prego. Come vi diceva la direttrice Silvia Misiti, avete una brochure sulla sedia dove troverete il sito internet della Fondazione IPSA per la ricerca scientifica e nel sito potete iscrivervi alla newsletter. Questa è un'ottima occasione per sapere quando ci saranno i prossimi appuntamenti qui al Masi, ma anche gli svariatissimi altri appuntamenti che organizza la Fondazione. Bene, come vi annunciavo prima, il tema del dialogo di oggi è l'invisibile e ne parleranno, come anticipato il dottore, Andrea Galvani e James Beacham, che torna a trovarci dopo il piacevole incontro proprio qui all'HAC di novembre. Andrea Galvani è un artista italiano che vive e lavora a New York e a Città del Messico. Riproduce le sue opere utilizzando strumenti specifici come formule ed equazioni. La sua ricerca e il suo interesse sono nella fisica e nella matematica. I suoi lavori trattano il tema dell'invisibile attraverso studi sviluppati in collaborazione con istituti scientifici e celebri ricercatori, in un sommarsi però di delle esperienze più svariate. Galvani rappresenta le sue opere con installazioni, fotografie, video, sculture e performance. Tra le sue opere, Instruments for Enquiring into the Wind and the Shaking Earth, un paesaggio incandescente fatto di equazioni luminose al neon, lavorato in vetro di Murano, con la quale l'artista descrive i fenomeni fisici come i movimenti delle costellazioni e le onde. Oppure l'opera Study on a Rotating Black Hole, con la quale l'artista descrive l'orizzonte degli eventi, ossia il centro fisico delle forze di un buco nero dove tempo e spazio precipitano e si deformano all'infinito. E invece James Beacham lavora al CERN, dove va a caccia di materia oscura. È membro della Atlas Experiment, uno dei team che ha scoperto il bosone di Higgs nel 2012. Anche Beacham tratta l'invisibile e ci fa riflettere sull'argomento proprio con questa frase, con queste parole. Le ricerche che facciamo sono affascinanti perché stiamo cercando di capire cose che sono letteralmente impossibili da sperimentare per gli esseri umani. Non potremo mai tenere in mano un bosone di Higgs. In particolare, la ricerca che svolge sulla fisica delle particelle contribuisce a contestualizzare l'esistenza e la posizione dell'umanità nell'universo. Io ora vi lascerei a questo dialogo tra Andrea Galvani e James Beacham e noi ci ritroviamo dopo per le vostre domande e le vostre curiosità. Grazie.
In the amount of time that it takes me to say this sentence, every single one of you will have about 10 billion particles of something called dark matter coursing through your body. In the same amount of time, every one of you has about 10 cosmic ray muons, tiny particles coming from outer space, passing through your head. There are things that are around us all the time, whether they're particles, whether they're voices that don't correspond to anything visual, but they indicate something that exists, and it's not something you can perceive immediately with touch or with sight, but you know it exists. Most of the research that we do at the Large Hadron Collider at CERN, where I work, is directly connected to this type of phenomenon. We're trying to ask questions and find out information about things that we literally cannot see with our eyes. And this, to me, immediately, had some overlap with your work, Andrea, and why I think it's partially why I think that, your work fits in very, very nicely with the history of particle physics and the type of questions that we're trying to answer. I was struck very recently by this image that I think a lot of people were. If you could switch to my slides, please. So this is an image that I think everybody knows at this point, but It's also, as you know, this is an image that went viral a few weeks ago or months ago because it's ostensibly an image of a black hole. But it's not really. And that's the thing. We literally can never see a black hole. A black hole, the object, the thing we're really interested in, is literally imperceptibly, to humans, physically impossible for us to see because light cannot escape its grasp. But this is the closest we can get right now to an image of a black hole. This is the closest that we can do. This is the best we can do right now. We're drawn right to the edge of human knowledge. And this image is awe-inspiring, and it just almost makes me cry every time I see it, and I've looked at it 100 times since it came out. But it's still, there's part of me behind the scenes that is still frustrated with an image like this because the thing that I want to understand is right there in the middle, and I can't get it. There's a limit, a physical limit. And that, trying to traverse that limit, the desire to traverse that, I kind of see that in a lot of your work. I don't know if you see the same thing in your work, but...
Definitely. I have to say that it's really interesting to think that for the entire lifetime of human being, we couldn't have any proof of this. And then now that we have it, we basically open another door, a big question. Because what we really want to see is what we can't see. The part that is inside, the one that is the door that can change everything and is improved. And it's curious that we start with this image because it's a direct link with a work I did in 2016 that is the result of a collaboration I started many years before. I present a sculpture. It's a 36-meter-long neon piece, and is basically the description of a black hole. I asked to Eloy Beato to describe a black hole, and what he did was a calculation, a really long calculation that was done and redone many times to fit the architecture where I present the work. And what you see is this series of numbers that illuminate the public through this cobalt blue light and open up to, again, this impossibility to go through this black hole. These invisible things that became visible, but still invisible. So my question is, can this invisible power produce visible result? And isn't this exactly what you try to do? I'm really seduced by the idea to research into the abstraction with all of this technology and moving around a dimension that is so unhuman, trying to rebuild a parallel universe where the temperature is actually cooler than the universe, and being there as a human being around this architecture, thinking that there inside maybe something is happening. I believe what you do is really creative and so powerful and radical.
It's certainly radical in a lot of different ways, and it's certainly crazy in a lot of ways too, for reasons related to what you intimate. Because you might think that it's kind of a bizarre thing, the fact that all the research we do at CERN, at the Large Hadron Collider, this 27-kilometer circular tunnel on the border of France and Switzerland, 100 meters underground, and we build these huge detectors that are 6 stories high, 46 meters long. It takes thousands of people from around the globe to come to Geneva and work on these things, and also to work on them from all around the world. And everything that we're trying to understand is the smallest possible thing in the world. It's really that, we're everything that we do at this facility is really asking, it might seem very complex, it might seem very complicated and weird and arcane, but it's really just trying to answer one very simple question. How small can I cut anything? And so, I mean, if you think about cutting and knives, it's nice that it's in Switzerland, right? So that's a good thing. But, you know, and also tunnels, we're very good at digging tunnels here. But the question at the heart of it is a very childlike question. It's not complex at all. It turns out that when you ask that question, you're secretly asking a much more profound question, which is, what was holding anything together to begin with? And so this series of this kind of dual, two very simple questions lead to this extremely rich structure and frankly very bizarre structure of the way everything works around us at its fundamental possible scales, the smallest possible scales. And it's radical, and even to me, I've been working on it for years, and I marvel at the awesome complexity of nature at its fundamental scales, and it's totally weird and bizarre and Baroque and you know, but it's, you know, it gets at the thing that you're talking about, is the fact that we go to such huge lengths to try to understand things that are literally impossible for us to see. We are, you know, we have this ring and we collide protons and sometimes other things. We accelerate them to almost the speed of light, 99.999998% of the speed of light. And then we slam them into each other millions of times a second. And the thing that we hope to discover will appear right there at the collision point, but it will only live for at most 10 to the minus 15 seconds. That's nothing. You will never be able to see this. You'll never be able to design a detector that can ever have the time resolution to see that thing. There's no way. We can only possibly see the indirect results of this collision. And so, in a sense, we are detectives. We can't possibly see the crime itself. We can only see the outcome and try to work backwards and to conclude what was down there. And there's a whole level of, you know, trust in logic and tools and reason that you have to go through it. Of course, if you don't trust logic, then that's a problem, and maybe that's a problem that we face in society right now. But the real thing we're interested in is always going to be hidden from us, and there's always going to be that barrier there.
One of the things I was thinking, listening to you, I can listen to you for hours, and I'm fascinating and realizing how beautifully you describe, again, something that is abstract and push our mind into a dimension that I believe is behind a wall of information. And I really see a connection with contemporary art when you are like seeing a piece, a sculpture, an installation, and you kind of like perceiving the surface of the work, the structure or the architecture of the piece, but what is inside this material, fragile and intangible, and what constitutes really the work is not visible, is like there, but is not there. So there is a fragile energy that surrounds or is contained into the shape, and that's art. And is constantly changing, and is like mixing, is dancing with the concept, and is transforming the possibility of an object. This is a glass, and all of a sudden can be a piece. And where is your particle? And how you describe it? What do you use to actually explain to me where the particles are? When we were discussing before, and when you were showing me some graphic, I also recognize how much in common we have. This instrument you use to explain your work, the fact that you were explaining to me that to see a particle, basically you see a little change into the position of a point on a line, if I understood correctly.
Yes. I can in fact show a version of that here.
So I see this and I see a piece. I see this and I see the potential of this and how many information, not only scientifically speaking, this graphic contain. The entire technology and the architecture and all of these 3,000 people are around this line and this little point moving. And the entire success of years of investigation are decided by a little point.
Yeah. Well, it's the success, okay, let's be clear, the success of the experiment is not whether we discover a new particle or not.
Right.
Every paper that we publish, and the overwhelming majority of the papers that we publish at the Large Hadron Collider, they do not show evidence of a brand new particle. Every one of those is a success, because that is new information about the universe that we did not have before. So I'm the kind of person that I think we should have, parties and celebrations with champagne every time we do not discover a new particle, because that's a success for our species. We have looked there. We can rule out that possibility within our data. We have a huge amount of data. We do different types of data reduction and analysis and kind of hone on places. Anyway, so you see what I mean. But so far, only one of our lines like this has shown a tiny little bump like this that has indicated the discovery of a new particle. And this is the so-called Higgs boson, or the God particle. We hate that name. But what you're saying is right. This is the thing we're looking for is so rare, is so subtle, that we have to build up. You see these numbers on the left-hand side getting larger and larger. That means more and more collision, more and more data. And eventually, you start to see this tiny, tiny bump that's almost imperceptible. And only with very clever statistical tricks can you convince yourself that that's evidence of a new particle. That's the extent to which we have to go. And I would love to see this turned into a piece of some capacity. But related to some of the work that you have done, it's kind of like you're saying, you see a piece in this. I have seen pieces of yours where part of the artistic work, part of the work itself, becomes not just the usage of a mathematical formula, to then make a sculpture or something like that, or to inform a photograph or something, but instead the graph itself. So I remember a piece of yours where there was some kind of three-dimensional plot that was also presented as part of the work. And I think that to me is such a profound statement because of it was what we were talking about earlier, this notion that physicists and scientists have a language that we use. We have a grammar that we use, and there's a visual grammar that's related to it as well. And just like any other language, any other grammar, you can get used to it. You can become accustomed to it. And we use it for good reasons, what we think. But is that it? Is that the only thing that we have? Is that like the extent of our knowledge? And what is secretly encoded in the visual representation that we put on the page? Which is, you tell me if I'm wrong, but that's part of what I was getting from some of your pieces, where these become part of the work itself, a commentary on this.
This is correct. So the graphic itself, the study itself, assume a value progressively bigger for me. Like most of the work was actually born through this type of dialogue that I start with people that in a way connect with me from a different perspective. And I see in this material a lot of potential. And I see that beside the necessity to inform scientifically about the data they contain, they are actually a language that independently is a proclamation of our state, where we are, what we have, and what's the possibility for the future, what we build, or how much we fail. And in my work, it's really important to also see the human side, the effort, the day we have every day, all of us, and the effort to live, and the difficulty sometimes to keep going. I just want to say something about a really simple phenomenon that is happening every day. The sunset and the watch, the time we have. These two things are connected, but so far away. And we measure time. We know that the sunset is going to be exactly at that time, but then what we are seeing is a nuclear explosion. And what we see is a nuclear explosion visualized through the perspective we geographically have. But that event is universal, is a cosmic event. And if we move from the perspective where we are, everything is going to change. We are not going to see the horizon, and we are not going to see the sunset in the way we know it. That thing is happening every night, and apparently is one of the things that all of us know for a fact. But then, how many of us could see the sunset from the moon? How many of us can see the sunset from a completely different galaxy? So this necessity to push my mind outside my perspective is the base of my work. And inside this, I really feel there are a lot of point of contact with the work you do when you have to face these invisible elements and bring with you every day in your daylight, drive with them, walk with them, talk with them. And I really see the potential of this talk too. And I'm really happy to be here, and I want to thank everybody to give me the opportunity to be in this conversation that is really productive. I'm having a lot of fun.
Yes.
And feel really good to be here.
I think what you said is really profound, and I honestly hadn't really thought about it in that perspective before. Perhaps if I think about it critically, some of my favorite poets probably would have commented upon this. Can we switch to Andrea's slides, please? But the thing that you said about, I guess looking at a sunset doesn't really have the same emotional resonance or romantic resonance if you say to your loved ones, like, wow, look, honey, at those insanely violent nuclear explosions going off in the distance, right? It's not quite the same thing, but, you get what I'm saying. It's somewhat humorous, but it evinces that so much of what we consider to be emotionally acceptable, our emotional and conceptual grammar is very contextual. It's about what we have as a set of, defined experiences that we can then relate to other people. And if you take it outside of that context, imagine what new emotions could be explored. Imagine what new things might be able to be interrogated. And that again, that's another thing that from your work that I've always found, fascinating. Breaking down these perceived, contextual grammars and languages that it's kind of like these assumed things that we have, like around society and culture, and from a physics perspective, we do it all the time. We're basically trying to push the boundaries of everything we do, stretch the boundaries, and keep going and farther and farther. But yeah, so you had, I think one of the first slides you showed here was also something that's really fascinating to me from a physics perspective, and did you have the piece where the mathematical objects were then put into neon sculptures at the top? Maybe it was the first image or something like that. Yeah, things like this. So, this one, and some of the other ones where you showed me that there was this installation with the white neon sculptures. You know the one I'm talking about. And then you have the dancers that went through.
Yeah, let me see if I can show it here.
That one is great to me because it takes back this language that we use in physics, because the language of physics is mathematics, let's be very honest. And no physicist would trust your conclusion, your scientific conclusion about the world unless you had a mathematical description of it. Yeah, exactly, this right here. And so, but those mathematical objects, despite what many people get the impression of when they're children, math is not about numbers. Math is not about multiplication. Math is not about complicated long division or algebra. It is those things, but math is really about relationships between quantities, relationships between forms. And when you do something like this, when you do a piece like this, to me what I see is all of these mathematical objects that I have in my head. I did a double major in physics and math, so I have like a kind of a pure math side of my brain as well. And you learn that math is really about abstracting forms in your head and thinking of the relationships between them. It's not about memorizing the derivative of, f of x equals e to the I pi or something like that. It's about figuring out the way things work in their relationships to each other, and it does have a spatial physical component to it. Not just mathematical symbols that then map into the physical world, but the symbols themselves. The math itself has like an internal physical spatial component. And so that when I see these writ large like this, it's like they're these glowing orbs. It's almost like they're the Platonic ideals come to life, come to physical life to me. It's kind of like I'm excited and also scared at the same time.
Yeah, the idea was to suspend the thought, the moment of the creation, the intuition, in a state that is not yet a shape. Is poor light. Mm-hmm. So is something that is literally illuminating us and illuminating through numbers. As you said, like numbers are a dimension, like a parallel dimension, abstract yet now completely a form. At the same time, they contain really complex concept, and they are the universal language in absolute. So
the ones that you chose for that piece, not this one, but the other piece were, I also recognize many of them from physics because they're, like thermodynamics equations and things like that. Maybe that's also why they scare me a little bit, because I'm like, homework. But they have these kind of universal laws behind them, these things that we have a mathematical description of, which again is a language. It's a way to describe the real world. But then it also raises, if I can yammer for a bit more, it also raises a really interesting question that I have grappled with a lot in my, just as a citizen, but also as a scientist, is you have to ask the question, you don't have to, but some of us do, what is the most fundamental description of our universe? Is it a physical description or is it a mathematical description? And that may seem like a weird question, but you think about it. A toddler, a small child, has a ball, and they throw the ball in the air. If it comes back down, they know that the next time they do that, it's going to come back down again. That toddler does not know how to do calculus. Okay, maybe some toddlers do, but it doesn't know how to do calculus, right? It doesn't know the mathematical. I know there's a very good mathematical description of why that happens. So in that sense, the physical world is more fundamental than math, and math is a thing that we as humans we invented to describe the physical world. But then I think about it from the other perspective, is that what about the fact that so much of our physical world I can describe really, really well with mathematics, so much so that it seems like the more fundamental description is in fact mathematics behind the scene, and we as humans discovered mathematics. What is mathematics compared to physics? Was mathematics discovered by humans, or was it invented by us? Do you have an opinion?
Really interesting question. Really interesting question. Because, like, it's definitely a language that we invent, trying to contain really abstract and complex phenomenon. Is a way to cut down the reality and reassemble it. And it happened also in a really specific time when the observation allow us to give the power to the mathematics, like the numbers. And it's difficult for me to say if I'm on the side of numbers or I'm on the side of action.
There's a bit of a tension in the question, though, right? And it's kind of built into that, this human desire to understand the world better, at least it is for me as a scientist. And again, maybe this is something I'm projecting onto some of your work, but I get that same tension. I see that same gap that exists between, you know, what it is that we're comfortable with understanding and what it is that we really, you know, we really want to understand. And, you know, again, not to put too fine a point on it, but the notion that it's really quite shocking. I mean, you don't have to take my word for it. I encourage everybody to do 6 years worth of, you know, a PhD in quantum field theory calculations. It's really worth it. But you don't have to do that to understand that there are certain things in the world, there are physical phenomena that are so complicated that follow mathematics so almost perfectly well, it's like shocking. It really defies belief. You're like, why should nature follow this mathematical principle so well? The perfect example is what I do. It's called particle physics, which is described by this thing called the standard model of particle physics, which really is just, if you know a little bit about group theory, which is a kind of math, and you know a little bit about differential equations, which is another thing, you basically get to describe everything that happens at its smallest possible scales. And it's so precise that this mathematical framework, it makes these very precise predictions as to what you should see in particle physics experiments if you do them. And every time we've done this experiment in the past, it's right there. Why should nature follow mathematics so precisely? And it makes you start thinking, is our universe really a mathematical object? And then we can go into a much larger discussion of multiverses and other universes. But, you know, it's
curious because you're talking about this, and then, like, what was running here is based on magic numbers. So the entire structure of this intervention I did many years ago was based on magic numbers and the geometry of them. Here I was building really fragile, structure that were moving with the wind and was like following the profile of the desert, of the landscape itself. But there is a lot of geometry and mathematics behind them. And now, like 10 years later, I see the connection with other works I'm doing. It is cosmological in a way. They like describe a really little space, so at the same time it seems to describe a constellation of different scale of space. And they move in a cycle of connection in a really special way.
Yeah, well, I was going to ask you about a couple of these too. If maybe you could go back to the balloon one and pause it there with the space bar, I think, and then one of these. So, in your experience, how maybe, I mean, maybe some people don't know this one. Maybe you could describe a bit more about where it was and how it was staged.
Yeah, so the work you see here, I don't understand why it's not stopping. The
Space bar.
Yeah, but it's moving.
Okay. Oh, F.
F.
Of course. Freeze. Okay, thank you.
Okay, so they change it. So this shot is from 2006 or 7. What you see is the Libyan desert, and the architecture of this black spot is built on the location. They're like a balloon filled with heliogas and physically installed on the location. You can imagine the temperature and the wind and like wherever surround a place like this, a rocky desert, the middle of nowhere, and we were like a group of crazy guys together working to build this structure that is only working from one singular perspective. So if you move slightly, you don't really see what this architecture is creating. And I did a series of similar intervention, traveling, but I also work with reflection like this. Here, for example, there are 3 mirrors that are reflecting the sun at the same time. I mounted the mirror on, like, wait, I have to give F. And the mirror are reflecting the sun at the same time. I don't know. Well, F. And I use this motor that are following the moon, the one you actually use generally to see the moon and shoot photographs.
So like it tracks the moon automatically.
Exactly.
Yeah.
So there is this perfect instant moment in which sun, camera, and object are together. And I was literally erasing the subject progressively by the light. So this series is specifically connect with perception and possibility to overlap different universe, different reality, like you said before. And I think it was really interesting what you were saying, because imagining us like the possibility to comprove the existence of a parallel universe could be the biggest revolution of human being.
Yes, and unfortunately it seems that such a demonstration is well beyond what our civilization could possibly do right now. But it's true that we do have a lot of circumstantial evidence that we may live in a multiverse. And I'm not sure if we want to go into the details, feel free to ask me afterwards. But we can touch about it a little bit, but really it's one of those questions that it's a question that scares people, let's be honest. And it even scares some scientists to ask those questions that are so profound, that are almost like, they're almost so bizarre that even scientists refuse to wrap their mind around it. And I say this not to be mean to my fellow scientists, but in my experience, when we ask this question, when we even intimate sometimes that so much of what we're learning about our universe, you mentioned magic numbers, right? Our universe seems to be filled with magic numbers, these constants of nature that we just measure, but we don't seem to have any real reason for why the values are the way they are. And physicists hate something that exists without a mechanism to explain it. We hate this. And so we go in search of the mechanism. And if you have an overwhelming number of these magic numbers, at some point you may be led to the conclusion that maybe these numbers don't have a reason that's internal to our universe. Maybe they're just one out of an almost infinite number of possible values. And the other values were chosen for other universes. Of course, I can't demonstrate that statement's true at all. I have no way to define what it means to contact another universe right now. You can't define what that means right now. But I can conceptualize it, and I can think that, I can posit that as a possibility. And some scientists then take the next step and say, because you cannot test it right now, it's not scientific. And really, there are people that they don't like this question. To my mind, it's clearly a scientific question because we followed the chain of logic and we arrived at this conclusion. It is, frankly, quite scary and it's weird, but it doesn't mean that it's not scientific. And I think that this breakdown of this inability of even the scientific mindset to assent to the possibility of the next step, the next thing beyond, indicates that, at the end of the day, we are still humans doing this research. We are still, it's both scary and also heartening at the same time. It's like, I'm frustrated because I want my scientists to say, yes, let's, come on, ask this question, let's push farther. But then I'm humbled by it. I respect the humanity, the humility in saying, I can't answer this and I'm not even, it scares me, this honesty, that I don't want to go to that level right now. One thing you mentioned, sorry, did you have something to say?
No.
So could we go to my slides for 1 second?
Right.
This one, something like this, yeah. So this is, it was related to what the intervention that you showed with the balloons and with the tires and things. So you mentioned that perspective matters there. You mentioned that if you were to look at this from a different perspective, the different balloons, it wouldn't look like much of anything. You just think you're a bunch of goofballs, hanging out in the desert, goofing around. But when you see it from one perspective, it makes sense, and you understand immediately the kind of geometrical symmetry and the reason why it exists. It's very similar to what happens in particle physics for necessity, because particle physics is all about symmetries. It's all about making your problem, it's very complex, and reducing it to something that's much more manageable. And that, because, physicists, maybe we seem like we're smart, but we're also, at the end of the day, we don't want to make our work harder than it actually is. We want to keep things simple. It's hard enough. And so this is a cross-section of one of our, it's a stylized version of one of our so-called collision event displays. So when two protons come together in the middle of the Large Hadron Collider, in the middle of my detector called Atlas, they collide, something happens, and then a bunch of stuff flies out. And we want to keep a snapshot of everything that happens as it flies out. And so there's all these red arcs and these big blobs of energy and things like that. So this is a stylized version of looking inside the Atlas detector, which looks like this. Yeah, here's a lucky guy who gets to stand here. So it's really 6 stories high. And it's designed in this cylindrical geometry, not just because it makes us life simple, but because that's the geometry that nature uses. That's the geometry that physics chooses for us. It suggests this is what we should use. And if you were to turn the detector to the side, it wouldn't make any sense, right? There's no reason to do that. So it's almost as though geometry, physics, mathematical symmetries, they dictate, well, maybe not dictate, they suggest exactly what you should do. And in a sense that indicates that they're a conduit through which sense and reason and meaning can be derived, and I really like that as an analog to that piece you were talking about.
Yeah, it's impressive to think geometry is what helps us to study abstraction in a way. If you pass me this sentence, and yeah, these balloons suspended in the landscape are clearly particles suspended into a dimension. Again, when I see this, and I remember the first time I saw an image of the tunnel published, and that's really a lucky guy because I don't know how many people could be inside. But is evident that this entire complex architecture designed to contain something that nobody can touch, nobody can see, is a piece of art. Is like, it is a complex architecture of the invisible. So I see a connection between the architecture of the invisible used to study the invisible and the architecture of the invisible used to shape the invisible, in my case, and how they touch each other.
Yeah, I mean, yeah, it's interesting you say that, because also some of the works that you produce are also asking a similar question about, obviously between the invisible, the thing that we're really interested in, the things that may dictate things around us that we might not formally assent to or like recognize all the time, but that are very important, and the thing that we can interact with, like an image or an artwork or a photograph or like a laptop of a sunset, on a pillar, because at the end of the day, the question that the types of questions that we're asking, they come from a kind of a similar place. And what was the one I was thinking of here? Did I have it in here? No, I don't know if I have it in here. Okay, well, this is not exactly what it is, but what we have at our disposal is this huge machine, this largest experiment in human history. It has thousands of people from around the world working on it, and it has billions of euros worth of public funds going toward this, right? And we do it not because we're going to make a product, because we're not. The Higgs boson only lives for 10 to the minus 23 seconds. You can't make a product out of it. You can't hold it in your hand. If we were to discover dark matter, you're not going to be able to make dark buildings out of it or something like that. But we do it because we're curious. We want to know these things about nature that we currently do not know. We're not satisfied with knowing what happened when the universe was 10 to the minus 15 seconds old. We want to know what happened when the universe was 10 to the minus 18 seconds old. We want to see things that are smaller than 10 to the minus 18 meters, right? That's what drives us. And so the things that we output from this experiment are results, like the plots, like these event displays that help us to understand about nature, or these plots that show, if you build up enough data, it demonstrates, yes, you've found a new particle, you've discovered the Higgs boson. But again, the thing that we want to know is the Higgs boson itself. We would love to see right in the middle here. That's what I want to see. I want to be able to hold that in my hand, and I can't. I never will be able to, ever. And it's so frustrating to be able to not be able to do that ever. But that, again, it requires, that frustration comes from the fact that it's physically impossible to do. And what it means is that I, as a physicist, I'm a filter in a way. When I create this image, when I create that plot, I am a filter between the thing we want to know, which is right there, and what I then show to you, which is this image. So I'm a filter in between that. The question then, the other part of me, because I trained as a filmmaker before I then became a physicist. I trained as a physicist. The other part of me thinks, why should we only let physicists be the filters between these two things? What would happen if we put, Andrea Galvani as the filter between that thing and what actually comes out? Or like Gerhard Richter or someone like that. What would happen? What would we get out of it? What would we learn? Maybe not anything scientific. Maybe you discover a new particle. But the point is not necessarily that you would discover something or that you would give us something new scientifically. It's that you or Gerhard Richter or someone would be able to give a new perspective, a different perspective on that effort, that huge amount of resources and time and effort that goes toward building this magnificent machine that has, sculptural and artistic qualities built into it already, but then that output, what would it be? I mean, you said in the middle of this conversation, you're like, yeah, I like to have this conversation. I wonder what's going to come out of it. I also wonder what's going to come out of it, right? Maybe what would come out of it if you wrapped your head around some of our data or the machine itself? I don't know.
What I was thinking is, why we do all of this, this necessity to understand and understand this door that open and close, this answer that is there, but then again there is a question. And the fact that this happened in your field and in my field investigation, anytime I'm getting close to something, then there is something else, and that this is the beauty of researching. And when it comes to investigate something that small that is actually invisible, and that short that is actually kind of also impossible to see, to document.
There's no shutter speed that is small enough, right, to be able to see that.
Exactly. So, it seems to me that the perimeter that we have is kind of like going away of the limit we are approaching. It's like there is this feeling of something that is disappearing. Like we can't touch it, but is in this tension in between, like trying to get these invisible, untouchable things. I see the answer. And you said something amazing that I brought with me in the plane when I was traveling. Is in one of the video I saw online, you said, the fact we are investigating, the fact we are asking ourselves, investing so much time into this abstract, huge concept that is the universe, is a way for the universe to study itself. And I felt was one of the most powerful statements I ever listened to. Imagining this universe with these billions of years of evolution to bring us to what we are, only for us to look to the universe itself. So this complex system that seems designed for the universe to look itself. And I found this image so powerful and like amazing in the connection that creates with everything. Because if it's true that we are the result of the universe trying to study itself, and we are nothing, a little fragment in these billions of years of evolution, but we are a little fragment that is so important for the existence of the universe itself.
Existence in the sense that our existence and the fact that we ask questions about the universe, depending upon your school of philosophical thought, us asking that question is the thing that brings the universe into existence, right? If different strains of ontology and, solipsism come into play, but you know what I mean? And yeah, I'm glad you liked that tidbit, because it's something that has haunted me since as a small child. This is the type of thing that I would wonder about. I grew up in southern Utah, in the western part of the United States, and I would often go, if you're a curious little kid, there's not a lot going on in southern Utah, and so you make up your own things. And so I would go out to the middle of the desert, and I would stare up at the night sky, and my friends and I would ask each other questions about the universe, and we would eventually get weirder and weirder questions, and then you'd get to this idea, and then, you know, about what's at the edge of the universe, what's beyond the universe, you know, what's, you know, not from a religious perspective, from a physical perspective. Is it a question that we can answer? And then you know, go to the library, because that's where you get new information. And I was a kind of a library guy, and so I would read a lot, and then you start learning what smarter physicists than you have thought about this concept. And this is an idea that has haunted me for a very long time, is that, like you were saying, you know, it was nicely put into this. This is that you know, diagram I was describing before we came down here. It came from a physicist named John Wheeler, and Wheeler's a very famous guy. Did you know, fundamental work in gravity, understanding the way, you know, planets move around each other and general relativity. Great guy, but then he also thought very critically about the behind-the-scenes philosophy behind all the questions that we're asking. And this picture of, you kind of have to ask the question, again, you don't have to, but some of us do. You ask the question, why does the universe have to exist? Does it? Is there a mechanism? Is there some kind of reason why the universe should have to exist? Is it inevitable? You can't really say that it is. I can't come up with a physical mechanism right now that will show you, yes, it is inevitable that the universe should exist. We do know it exists. But again, as you were intimating, we know how large the universe is. It's gigantic. It is beyond comprehension. And in fact, the part of the universe that we can see is even smaller than the entire universe. It's a tiny subset of the whole thing. We are so insignificant. We have only been around for such a tiny fraction of time compared to all of the time that's ever existed. And we're only on one isolated little solar system in some podunk galaxy in the middle of nowhere. It's like the universe, to a certain extent, doesn't even acknowledge that we exist, except for exactly the thing you were saying. Is this thing that's haunted me since I was a child, is that our universe eventually gave rise to us. And the universe, in a sense, had to exist long enough. It had to exist 13.8 billion years to eventually evolve at least one species like us. Maybe there are others. I can't statistically put a number on that. If any scientist tells you that they can put it, there's a 25% chance that there's other people in the universe, that's nonsense. But we do know there's at least one species like us that asks questions about ourselves. We are self-reflexive. We ask questions about where we came from, the universe around us. And as you're saying, that's the way I put this in this talk, right? Is like, it's both terrifying, haunting, and also somewhat comforting, the fact that when we as humans ask questions about the universe around us, we are the method by which the universe asks questions about itself. And this is, something that John Wheeler put into this diagram, right? It's the universe is this you, which eventually existed long enough to evolve something that then can look back on itself and bring itself into existence. And, call me silly if you like, but this diagram has haunted me for my entire life.
Amazing.
What's our time scale? We can keep going for many, many hours, if we... Was there any other main things I was going to talk about here? No, we can put some stuff here. Yeah, did you have an image? Can we switch to Andrea's slides, please? Yeah.
About the universe, where you were saying, this is an action I did a few years ago. I asked online to people to shoot the sky from different perspectives, from different places in the world. And what you see are on the bottom are the coordinate of the exact location where people were shooting. What I was collecting were segments of perspective, but at the really end, if you think about 200 people, 300 people, 5,000 people, the number of people are not helping to complete the image of this infinite, huge universe. Segment of space that are bringing us light from the past. What we are nothing, really nothing, in front of this sublime black mystery that is coming to us in a fragmented way, but is actually a clear and strong call for us to understand it.
Yeah. What are some of the comments that you got from people that participated in that? Because
it's interesting how in the work itself, it's kind of like separating from the process of the work itself is separating from the final result of the work. And it built progressively, and they were kind of not they didn't understand in the moment what they were doing, and then all of a sudden it came to a reality, and they were part of a global action. You know, they were all together collecting a moment that is uncollectible, and it will be always missing. Sometimes the work is rebuilding, sometimes the work is deconstructing. This that you see in the back is a column. Apparently it's a column of book, and it's actually a column of books. But these books are selected and recollected from the university. Every year, each university have a limit of books in the library, so they collect new books and they take off some of the titles. And this is a column of obsolete books. Books that became obsolete, but they are basically the base of the new books that we are writing. I like to speak about this work because in a way is a symbol of what we are. We can only proceed by stratification of information. We build our architecture, our knowledge on different layers, and then all of a sudden some of them are not important anymore, not at the point that were before. And then we know that nothing is obsolete because everything is necessary and is part of this evolution that you were talking before. So this is an infinity column. It's an ongoing project. Each column is unique and can be installed on the top of the other one. They literally want to reach the sky. They literally want to be the bridge between the ground and the sky. And what's in the middle is our knowledge, but also our failures, our impossibility to complete exactly like before, something that is bigger and full of unknown.
I like that one too, if I can comment on that while it's still there, because to me it also it's both things. And again, it's one of these things that I love about your work is that it doesn't shy away from, and in fact very bravely like embraces dualities, embraces tensions that are built in to so many concepts in society that we take for granted, right? And one of them, of course, is the notion of progress in society or science, right? Both things, and the 20th century, of course, has demonstrated to us that progress in society is, it's very fits and starts. It's not like a linear thing, right? And we're also facing that again today, with the way politics is evolving throughout the world. The erosion of civil rights, when we thought we had people solved civil rights, and it's crazy that this is happening again. But to me, I look at this from one perspective, and I think, okay, yeah, this is a record of our, scientific maybe failures in one perspective, but it's a record of the things that came before our current knowledge, right? And so what you're saying, it's a success in that way. And to me, I see this as a tower of like our collected history of knowing more things. And it's kind of like in physics, right? I mean, you don't really, the new physical idea, the new physics ideas, and to be clear, we have a very large number of open questions in physics that we need all of you students in the room to help us solve, because we need new ideas. Those new ideas that then help us solve the current problem, they're not going to replace the existing paradigm necessarily, but they're going to add on to it. They're going to expand it. And this is the way, if you know Newton and Galileo versus, a good one is Newton versus Einstein. Newton had the best way of describing, the way planets and things moved around in the sky, until Einstein came around and said, that's not wrong, but we have to change it a little bit. And so he had a slightly different version of the math that describes what we see better. It doesn't mean that Newton was wrong. Newton was right completely in one certain realm. If you then need to go a little bit more deep and a little bit more precise, then Einstein is the thing you use. But it doesn't mean that the prior knowledge was wrong. And so I see a column like this, and I see that it's a good visual exposition of the tower of collected knowledge that is also somewhat, teetery. It's possible for it to fall over. It's possible to have a collapse again. It's possible to have a society that doesn't recognize, the utility of what came before.
While you were talking, I was trying to find another image. The N action 1, what you saw before was the N action 9. Is a similar action. I record the sunrise over the sea, and from 30 different locations. And what you see in a space, all of a sudden, is one unified space. And this unified space is a space that contains the same time. The sun is rising over the sea at the same moment, and is exactly what I was describing before. It is a cosmic event. What happened is that the humidity of the air, the weather itself, is interacting with the light and changing it. The perception of the color is related with the temperature of the air, with the wind. So it became a kaleidoscope that contained different perspectives. But again, I realized doing this project that when I start, I really wanted to be precise. I really wanted to cut down the space every 200 kilometers, distribute all of these people and my cameraman recording the event with a mathematic a technique. What I realized is that in the process, I progressively approach, again, abstraction. And this is a interesting thing, like being precise, not necessarily bring you to logic and result. Sometimes you jump into abstraction again. And in this specific case, you're facing a sphere and a line. This sphere doesn't really have a side. It contains all of them. So again, what you see is not exactly what it is invisible in reality. Like you see only partially what in reality is the event. And the event is abstract and is similar to this tunnel where a new particle can be created.
And I think this is humbling and profound too, this piece, because to me, I also look at it from exactly what you're saying, and I see a very clear visual representation of the fact that a multiplicity of perspectives is obviously better than one particular perspective, and the multiplicity, but it still can never completely represent the event itself, which is invisible, which is completely imperceptible to us. Multiplicity of perspectives gets us closer, but it's still just out of reach, and that's both scary and beautiful at the same time.
Exactly.
Dovrò intervenire, non sarà mai il momento giusto per fermarvi. Thank you, James Beacham. Grazie, Andrea Galvani. Io credo che questo dialogo non può avervi lasciati indifferenti e abbiamo sicuramente qualche minuto per qualche vostra curiosità o domanda. E chiedo magari, grazie. Ci sarà anche la traduzione, quindi potete fare sicuramente le domande in italiano. La raggiunge una signora.
It's a question for the physicist,
Okay.
because I am also one.
Great.
At the beginning of your talk, you mentioned that at the Large Hadron Collider you are hunting dark matter. And there are, evidence that it should somehow exist. There are even theoretical models, the WIMPs and so on, which support this idea. But since, I think, 15, 20 years, we know that the universe is not only expanding, but is accelerating its expansion. And there is, to explain that, there is a form of energy, the dark energy, not the dark matter, the dark energy. And nobody knows at the moment what this is exactly. If you make a simple estimate, you are 120 order of magnitude apart, so it doesn't work. Okay, do you have better models for that at the moment, or is still a phantomatic quantity?
Currently, it's still very mysterious. The answer is that no, we don't really have a better idea, which is why I was pointing to any possible student in the room, help us, we need new ideas. And so, of course, as you pointed out, there's two different things here that we use the word dark to, we attach the word dark to. One is dark matter, and one is dark energy. And dark matter, as you said, we know it exists. Let's be clear about that. I said at the beginning, all of you have about 1 billion particles of dark matter going through your body every second, and you've never felt it. We don't know what it is. But that's under the assumption that it is a particle. We don't know that it's a particle. What we do know is that things behave in the sky much weirder than they should. Basically, if you take every galaxy, like your favorite Hubble photograph of a spiral galaxy, they're gorgeous and beautiful, and the beautiful arms, and then you count up all the stuff that you can see with your eyes, all the stars, and that gives you an estimate of the amount of matter there should be in that galaxy. It's visible matter. And so then you take your favorite textbook on gravity. I assume you all have a textbook on gravity next to your bedside like I do. You take that and you just put the matter into the equation that tells you how fast a star should be moving as a function of how far away from the center of the galaxy it is. Just a straightforward calculation. You can do this yourself. And then you go out and measure how fast that star is going. It's going way faster than it should. So much faster that in principle, the galaxy should split apart Galaxies should not even exist if what we observe right now is based upon only visible matter. So therefore, one of two things is wrong. Either gravity is wrong, and it's probably not, or there's more stuff there than what we can see with our eyes. And if it's not light matter, it's dark. So we know that something is up. And the simplest possible explanation is that it's extra stuff that's floating around all the time that just doesn't bump into us very much, almost never. And so that we know is something that exists. The thing we don't know is whether it's a particle or if it's something else that's very arcane and weird and we don't really have time to go into. The other part is dark energy, which is what you said, is there's something that seems to be driving the expansion of the universe. So the universe is about 13.8 billion years old. A few billion years ago, and for most of its history, it was kind of expanding at this kind of constant rate, except at the very beginning. A few billion years ago, suddenly it started to speed up and accelerate. And we don't know why this happened. And the answer to your question is, we don't currently have a good model for this. And the best ways to describe it right now are really, really hard to test. And they're really, really hard to come up with some kind of experiment to test right now. Again, there are some kind of alternate ideas, and in fact, I don't know if we have time to go into this, but one of the alternate ideas that would in principle explain both dark energy and dark matter would be that other thing that I said is probably not wrong. Maybe our understanding of gravity is wrong, but not wrong, but we have to ameliorate it. We have to change it in the same sense that we were talking about in the talk, right? You have this column of knowledge. Maybe Newton is down here and Einstein is up here. Maybe, or he's being used right now, but maybe there's another version of Einstein that will describe what we see better and not require the need for this extra dark matter particle or something that's floating around us all the time. And in fact, a colleague of mine in the Netherlands has this totally wild and probably wrong idea, but it's a totally wild idea that our universe is, what we see as gravity is not really a force, and what we see as dark matter is not really a particle, but that gravity is an emergent phenomenon that emerges naturally when the basic description of the universe is quantum qubits, and we live in a hologram. So again, I can't really go into detail with this. There's math behind it. He's a real physicist, trust me. But it's one of these things that every skeptical person, and all scientists, in fact, they go, huh? Hold on. And you should. That's what we do. Science is about submitting your idea to everyone so that they can scrutinize it to make sure that it withstands scrutiny. And that's the kind of we don't know that answer, and that's the kind of thing that we're butting up right against the edge of human knowledge, and we don't know what where the revolution is going to come from. It has to come from somewhere, because we can't explain what we see now. But I don't know where it's going to come from. Hopefully from somebody in this room.
The drawing in the back, this apparently really simple geometry, they are part of our idea about the solar system. How many times the solar system idea changed, and how much violence and how difficult it was to actually change the position of one point, the sun, the Earth, or other planets. It's curious and connect with these possible words, possible perspective. They are changing, and we are part of this fight to understand.
And this is a really nice piece too, because it has this beautiful, really nice line drawing, evocative of the way, the diagrams that you would see in a textbook. But it's a completely visual representation of, again, this notion that it's related to the column of books in a sense too, because this is it's like an imprint of history in a way. It's like a diagrammatic history of knowledge, and how so much of it's kind of an object lesson too for humanity, where science exists for a reason, right? I mean, it's there because we as humans we like to believe things that are totally not true, just because we're emotionally attached to them, or we like to find patterns where there's not really a pattern there. And science is about making sure, hold on, okay, we're all human, but we can't we can't build a bridge based upon your belief, in love. Okay, that's not good. We instead need something concrete, something real upon which to trust that our conclusions about the world. And so many attempts to explain the way the world was in the past, the way the world is in the past, were driven because somebody had an emotional attachment to something. It's like, of course, the Earth should be the center of the universe. Of course, the data don't back that up. And so, but then people had to invent these very, very crazy ideas that didn't work. And yeah, exactly. This is a mishmash.
Exactly. This is all of them together. So it's a collapse of time and space.
Ecco, c'è un'altra
Yes.
domanda.
Hi, so first of all, thank you for being here. It's a great opportunity. So you mentioned earlier that math is able to describe events in a pretty accurate way. So, but in the real world, I think human beings are not as predictable and describable as particles, for example. And my question is, do you think that in the future there may be a model, mathematical module or physical module that is able to describe human beings the way it describes particles, for example? And if so, what's the consequence?
My honest opinion is that it's in principle possible to have this mathematical model that would describe human behavior, because you should in principle be able to model the human brain as a computer, right? Because at its heart, what we refer to as consciousness, the thing that I refer to as I, is a series of neuronal impulses, which are electrical impulses at nature. So in principle, I should be able to model this, and in principle, I should be able to have a simulation that will then accurately describe the way humans behave. I think that if you just look at the amount of computing power you need to do that for a single human brain, it's so far beyond what we have the possibility of doing, even in the near future. I don't see it as happening anytime soon, to be honest. I mean, there are certain people that are either scientists or quasi-scientists that talk about the singularity, and there'll be a moment at which computing power suddenly outpaces everything that humans can possibly do, and everything is modelable, and the universe would be described as a computer. This was supposed to happen in 2000. This is supposed to happen in 2005. This is supposed to happen in 2012. It's a fantasy that we use, that like people use for pop science books and things like that. But the honest scientific answer is that yes, any physical system should in principle be able to be described by a mathematical model. Certain ones seem to be beyond a level of complexity that's within reach, within possibly our civilization. So I don't think we have to worry about that honestly at the moment. But yes, the answer, I think it could in principle be modeled. The consequence for that, yeah, I mean, if you were to write a science fiction book, and science fiction books have been written about this, that someone is able to model the brain, someone is able to simulate the brain, and then at that point, what is the difference between a simulated brain and a real brain? And you can think about the consequences on your own, but yeah, I really don't think that this is something that we're going to have the capacity to do anytime soon.
Io vi ringrazio, se non ci sono altre domande, vi ringrazio da parte della Fondazione IPSA e del MASI per essere stati qua così numerosi e interessati a questo dialogo tra James Beacham e Andrea Galvani, e vi invito a prendere un aperitivo in compagnia proprio qua fuori, nel piazzale dell'Hack. Vi auguro una buona serata. Grazie.